Hey y'all. Good morning. I unfortunately could not be at school today. Everything is fine. I'll be back tomorrow. I just had a couple of doctor's appointments that I scheduled all on the same day, so don't have enough time to even be here. So what we're going to do today is start our statistics unit. And what you're going to need first is this packet. Packet of, I think, like 13 pages, I don't remember. Front and back, this is or at least the first part of a statistics textbook. Okay? Now, this packet is yours to keep. I really would love for you to hang on to it and not lose it. If you do lose it, this scan is also in your Google Classroom. You'll see it at the very top, statistics textbook. Okay? So, what I need you to do is first grab a sheet of paper. Take a minute, grab a sheet of paper. Remember, there is paper in the back of the classroom. And what we're going to do here is read section 1.1. So no, you're not reading this entire packet, just section 1.1. That would be pages 1 through 9. Okay? So just the introduction to the practice of statistics section. Okay? Now, go ahead and flip back to page 9. And page 9, this is like 2 and 1, so there's 1 and 2, 3 and 4, 5 and 6, 7 and 8, 9 and 10. Page 9 is this page that has this table about Australia, Canada, France, Morocco, Poland, Sri Lanka, and the United States. You're going to read all the way down to here. So when you get to this 1.1, assess your understanding, you're done reading. Okay? There's a lot more left in here, so please do save this. Okay? Before you get started reading, I want to zoom in on these concepts and vocabulary from page 9. As you're reading, I would like for you to keep these questions in mind. Now, I would love for you to be able to answer 1 through 14, but do not worry about 6, 7, or 8. 6, 7, and 8, don't worry about them now. They deal more with experiments, and honestly, I would rather you wait to worry about that until we get to our experiment section, which is 1.5. Okay? So, as you're reading, what I want you to do for your notes is 1, define statistics. Write down 1, define statistics. And then as you get there, write your answer. Now, you don't need to write it word for word. You can summarize it in your own, but make sure you kind of get the core concepts there. Okay? We will talk about these 14 questions tomorrow at the beginning of class. So how this is going to work is in a minute I'm going to tell you to pause the video, and you're going to take, depending on your reading time, about 20-ish minutes to read, and jot down those notes. If you need more time, just tell your sub to give you more time, okay? And then we're going to pick back up and start talking about some of these skill building questions, like 15 through the rest of it, okay? So, read pages 1 through 9. This is your stopping point. And by the way, there's these little boxes throughout that say, now work problem 51. Don't worry about that. Don't work the problems in the middle. Just try to answer these key concepts. So, start here, getting the information you need. Statistics is a process. Start there, okay? Take about 20, 25 minutes. Make sure you're trying to answer those questions, okay? So, pause the video, give yourself a good second, and then we'll come back together. Okay, that feels like enough time. So, again, we're going to talk about these questions 1 through 14 for the most part. But the point that I'm kind of hoping you got from all of that is with statistics, there really is no one answer. The goal of statistics is to get an idea, an estimate, an approximation about how things are without finding the actual 100% answer. Because as we're going to talk about in section 1.2, getting the final definitive answer is sometimes pretty hard. Okay? So, let's first look at the bottom of page 9 at this skill building section. In problems 15 through 26, classify the variable as qualitative or quantitative. Okay? So, all of these are a variable of like a question you could ask somebody. What is your nation of origin? That means, are you from the United States? Are you from Mexico, Canada, France, Germany? Those kind of things, okay? Classify all of those as qualitative, meaning they're kind of an answer that if you did math with it, it wouldn't make any sense. An example of a qualitative variable is, what's your favorite color? Mine's red. Yours might be green. You can't find the average of red and green to say, hey, the average favorite color is brown, or whatever that would make. That doesn't make any sense. So favorite color is a qualitative variable. Quantitative variables, on the other hand, are variables where it makes a lot of sense to do math with. For example, age. I'm 25. You guys are probably 17, 18. We could say the average age in the class is somewhere between 17, 18, and 25. Okay? So, take a minute, pause the video, and write down qualitative or quantitative for 15 through 26. So go ahead and number 15 through 26 and write your answers. Pause the video and we're going to come back together. Okay, so let's talk about these. Number 15, your nation of origin. It would make no sense to try to find the average or the sum of all the nations of origin. Now, you could totally find the most common nation of origin, but doing mathematical calculations with names is nonsensical. So nation of origin for 15 is qualitative. Number 16, the number of siblings. That is quantitative, because you could find, and it would make sense to find, the average number of siblings. I have one brother. Y'all might have 5. Number 17, eye color. That is qualitative. Can't do math with eye color. Now, 18 is interesting. The number on a football player's jersey. Now, I'm not a big sports nut, but I do kind of know that the number doesn't represent much of anything. And if you were to try to find the average of all of those numbers on the back of a football player's jersey, you wouldn't come to any sort of meaningful answer, right? So even though it's a number, the number on the back of a football player's jersey is qualitative data, or a qualitative variable, excuse me. Number 19, the grams of carbohydrates in a donut. That is quantitative. You can find the average number of carbs in a donut. 20, the number of unpopped kernels in a bag of ACT microwavable popcorn. That is quantitative. 21, the assessed value of a house. Quantitative. 22, phone number. Qualitative. Finding the average phone number doesn't make sense. Not worth your while. 23, the population in a state. Quantitative. That's a number. It'd be nice to find the average population of all the states. That's some math that would be meaningful. 24, the cost in dollars to fill up a 2005 Chevy Corvette. That would be quantitative data. Numbers, do math with it. 25, student ID number. It is a number, but it's qualitative data. Because finding the average student ID number, yeah, you could find the average, but what good would that do for you? And 26, marital status. That means like, are you single? Are you married? Are you divorced? Are you widowed? All those kind of things that people could answer on like a census, right? That is, again, qualitative data. Or, excuse me, I keep saying data. that would be a qualitative variable. So and I wrote the answers out here, and you'll see I wrote categorical beside each bit of qualitative data, because in statistics you may hear categorical used interchangeably with qualitative. And I actually like the word categorical because I keep weirdly emphasizing qualitative, quantitative. And categorical, it means the same thing as qualitative because each of the answers for a categorical variable or for a qualitative variable would be a category, like single, married, divorced, blah, blah, blah. So here are the answers for 15 through 26. Pause the video if you need to copy those down. Again, qualitative and categorical mean the same thing. Qualitative are variables in which doing math with the individual data values wouldn't make any sense. Quantitative variables are variables in which doing math with those answers would make some sense. You could find the average age, the average height, the average weight. Okay? Now, let's move on. Let's look at problems number 27 through 38. Now, all of these are quantitative variables. But what we need to do is determine whether they are discrete or continuous. So these are all numbers that you could do math with, but we need to determine if they are discrete or continuous. This may seem kind of like, why are we worried about this? But later on in statistics, it's important to recognize whether your variable is discrete or continuous. Discrete boils down to you have to count to get the data value. Continuous boils down to you have to measure to get the data value. Discrete, let's see, is this an option? I don't want to accidentally tell you an answer. A discrete variable would be like how many siblings you have. You could have one sibling, two siblings, three siblings, four siblings, five, or so on. But you can't have 4.5 siblings. You just can't. That doesn't make any sense. And you count how many siblings you have. Continuous, on the other hand, those are variables in which you would have to measure somehow. And there's like an infinite amount of in-betweenness. So like, for example, how tall you are. You could be 5 feet or 6 feet tall, or 5.5 feet tall, or 5.25 feet tall, or 5 and an inch, or 5.5 an inch, or 5.25 an inch. And depending on how precise of a ruler you have, you could always find like 5.5 inch, 5.25 inch, 5 1/8 inch, 5.01 inches, and that makes things continuous, where there's always going to be one more in-between value. Okay? Again, discrete variables, you have to count them. You just count them on your finger. Continuous variables, you measure. So take a minute for 27 through 38. Go through it and label those all as discrete or continuous. You can just put a capital D or a capital C for each of those. Again, pause the video, take just a couple minutes. Think really carefully. A couple of these are a little tricky. And then we'll come back together. Okay, again, pause the video if you need more time. So, number 27, the runs scored in a season by Albert Pujols. I assume that is baseball runs. Okay, so the runs scored in a season would be discrete data because you either scored 5 home runs or 6 home runs or 7, but not 5.5 home runs. Okay, so that would be a discrete variable. 28, volume of water lost each day through a leaky faucet. That would be continuous. Mostly because you have to measure that somehow. 29. Now, your A-team counterparts and I had somewhat of a a lengthy conversation on the length of a country song, whether or not it's discrete or continuous. The answer is, in my opinion, and in this book, continuous. Because whenever you're recording something, depending on, like right now, this says we're 15 minutes, some odd seconds in, and it doesn't show in between seconds, but you can measure using like a really fancy stopwatch between this in seconds. And the thing that makes it continuous is the fact that you would be measuring the length of the country song, not counting. I mean, unless you're going 1, 2, 3, 4, 5, but still the measurement is the fact that you're, right? So the length of a country song is continuous. 30. The at-rest pulse rate of a 20-year-old college student. This would be discrete. That's because you actually count the pulse rate. You just do this and you count 1, 2, 3, 4, 5. And there is no like 22 and a half beats. It's just 22 beats or 23 beats. Okay? 31. The number of sequoia trees in a randomly selected acre of Yosemite National Park. That would be discrete because you're counting the trees. 32. Weight of a randomly selected hog. Well, whenever you measure, or whenever you get the weight of that pig, you had to measure it using a scale. And that hog could be 20 pounds or 21 pounds or 20 and a half pounds or 20 and a quarter pounds, and you get what I'm saying here. So 32 is continuous. 33, temperature. Temperature is always going to be continuous. You have to measure it. 34, internet connection speed in kilobytes per second. That would also be continuous. Okay? You can't count your internet connection speed. It's something you have to measure. 35, the number of tornadoes in a year in the United States. Well, you're going to count those tornadoes, and there's no such thing as 5.5 tornadoes. 36, the points scored in an NCAA basketball game. Discrete. Again, with all those kind of sports things, you're counting if there's 5 points or 6 points. 37, number of donors at a blood drive. That would be discrete again because you're going to have 10 donors or 11 donors, but not 10 and a half donors. And lastly, 38, the air pressure in pounds per square inch in an automobile tire. That is something you would measure. That is continuous. So, here are the answers. You can see that for number 30, I actually wrote a different answer at first and then crossed it out because I wasn't 100% sure on how you measured pulse rate, and I thought that would be like a blood pressure cuff, but it's continuous because you count. One of my lovely A group students informed me of how pulse rate was measured. I'm not a science guy. I'm not a doctor. Take a minute, copy all that down if you need. All right, we are going to move on to this next section, problems 39 through 44. So for each of these, a research objective is presented, and it just briefly explains what someone did to get some good data. Okay? So, what you need to do for each of these is identify the population and the sample in the study. Now, I'd like to do the first couple together, and then you can pause the video. So we're going to do 39 and 40 together. 39. The Gallup organization, that's a group that does a lot of polling. The Gallup organization contacts 1,028 teenagers who are 13 to 17 years of age and live in the United States, and ask whether or not they have been prescribed medications for a mental disorder such as depression or anxiety. So remember, a sample is just the people who we contacted. A population is everyone who could have been part of that sample. A population is everyone. A sample is just a handful of people from the population. So, here, the population is all teenagers aged 13 to 17 who live in the United States. It's kind of specific, but it's all teenagers aged 13 to 17 who live in the United States. The sample that was taken by the Gallup organization is just the 1,028 teenagers whom the Gallup organization contacted. Again, population, all teenagers aged 13 to 17 who live in the United States. We want to specify that we're talking about teenagers aged 13 to 17 because they're doing this research and they're not contacting 19-year-olds. They're also not contacting 14-year-olds that live in Texas. Why did I say Texas like it's a different country? That's embarrassing. They're not contacting 14-year-olds who live in Mexico. Okay? So, population, teenagers aged 13 to 17 live in the United States. Sample, 1,028 teenagers who were contacted by the Gallup organization. Number 40, a quality control manager randomly selects 50 bottles of Coca-Cola that were filled on October 15th to assess the calibration of the filling machine. So, the population here would be all Coca-Cola bottles that were filled on October 15th. The sample that was taken would be those 50 bottles that the quality control manager opened to check the calibration. Again, the population would be all Coca-Cola bottles filled on October 15th. And the sample would be the 50 bottles that the quality control manager took. So what I want you to do is 41, 42, 43, and 44, just 4 more. I want you to write down the population and the sample for each of these, and then we're going to talk about them. Take a minute, pause the video, and then we'll come back together. Okay, 41. A farmer wanted to learn about the weight of his soybean crop. He randomly sampled 100 plants and weighed the soybeans on each plant. The population would be all of the soybean crops, at least that he owns, okay? Because he wanted to learn about the weight of his soybean crop. So it's all soybeans on his farm that he owns. The sample would be those 100 plants that he harvested and then weighed. Population, all of that farmer's soybean crops. Sample, the 100 plants that he harvested and weighed. 42. Every year, the United States Census Bureau releases the current population report based on a survey of 50,000 households. The goal of this report is to learn the demographic characteristics of all households within the United States, such as income. The population is actually explicitly written in that. All households within the United States. That's the population. But the sample is those 50,000 households that the United States Census Bureau actually surveyed. Population, all households within the United States. Sample, the 50,000 households they surveyed. Number 43, it's longer. Folate and hypertension. Hypertension is high blood pressure. Researcher John P. Foreman and co-workers wanted to determine whether or not higher folate intake is associated with a lower risk of hypertension, aka high blood pressure, in younger women, meaning women aged 27 to 44. To make this determination, they looked at 7,373 cases of hypertension in young women and found that younger women who consumed at least 1,000 micrograms per day, and then there's some weird μg/d of total folate, meaning dietary intake plus supplemental, had a decreased risk of hypertension compared with those who consumed less than 200 micrograms. Okay, so let me summarize this. They want to know whether or not taking this vitamin supplement called folate helps maintain lower blood pressure. Okay? Yeah, okay. So, the population here is kind of weird. It's all younger women, people aged 27 to 44. So, all younger women who are aged 27 to 44. Okay? That is their population. The sample that they took was the 7,373 younger women with a history of hypertension. Okay? And it makes sense that they only took a sample of women with hypertension because it wouldn't make any sense to study hypertension and the effectiveness of folate on people who don't have hypertension to start with. Okay? And that's pretty much that on that. And number 44, a large community college has noticed that an increasing number of full-time students are working while attending the school. The administration randomly selects 128 students and asks this question: how many hours per week do you work? The population will be all full-time students at the community college. Notice it said full-time students because they want to know, or they've noticed that an increasing number of full-time students are working while attending the school. The sample that was taken was there was 128 students who took the survey. All right. We are going to do 2 more together, and then we are going to be done. Okay? So 45 and 46. Each of these, there is a study that is described here, and we need 4 things. We need the research objective. You need to tell me what the research objective was. You need to identify the sample, list the descriptive statistic, and then state the conclusion that was made by the study. We're going to do 45 together, and then I'm going to give you a couple minutes to work through 46. So let me read 45. A cure for the common wart. A study conducted by researchers was designed to determine if application of duct tape is as effective as cryotherapy in the treatment of common warts. Now, cryotherapy, it actually explains it later. That's where they dip a Q-tip into liquid nitrogen and then hold it on the wart and freeze it off. Okay? So they want to know if the redneck sounding solution of duct tape to the wart is just as good as or better than cryotherapy. So here's how they did it. The researchers randomly divided 51 patients into 2 groups. The 26 patients in group 1 had their wart treated by, applying duct tape to the wart for 6.5 days and then removing the tape for 12 hours, at which point the cycle was repeated for 2 months. The 25 patients in group 2 had their wart treated by cryotherapy, which is liquid nitrogen applied straight to the wart for 10 seconds every 2 to 3 weeks for a maximum of 6 treatments. Once the treatments were complete, it was determined that 85% of the patients in group 1 and 60% of the patients in group 2 had complete resolution of their warts. The researchers concluded that duct tape is significantly more effective in treating warts than cryotherapy. Now, before we get started with A, B, C, and D, y'all, I had no idea that it was a treatment to put duct tape on warts and rip it off? You leave it on for 6.5 days and then take it off for 12 hours and then put it back on for what? I've never heard of that. Never. But this study, the efficacy of duct tape versus cryotherapy in the treatment of the common wart, apparently so. Wow, okay. So, there are 4 things we need. A, identify the research objective. It's there at the top in quotation marks. To determine if application of duct tape is as effective as cryotherapy in the treatment of common warts. Right there for you. B, identify the sample. The sample is those 51 patients. Now, I know they were split into 2 groups, but all of them are part of the sample. And I would assume that the sample is 51 patients who had a wart. because, but whatever. C, list the descriptive statistic. So remember, a descriptive statistic is a number that summarizes the data that you got. Here there are two descriptive statistics, one for both of those groups. The descriptive statistics are that 85% of patients in group 1 and 60% of patients in group 2 had complete resolution of their wart issues. D wants to know, what conclusion did the study make? Well, it says it at the very end there. The researchers concluded that duct tape is significantly more effective in treating warts than cryotherapy. So let me go back over that real quick. The research objective was to determine if application of duct tape is as effective as cryotherapy in the treatment of common warts. B, the sample was the 51 people. C, the descriptive statistic is that 85% of patients in group 1, 60% of patients in group 2 had complete resolution of their warts. D, duct tape is significantly more effective in treating warts than cryotherapy. That was the conclusion. So what I want you to do is read over 46 about early epidurals, and then pause the video and read over that, and then we will talk about that, and then we will be pretty much done. And I hope you paused the video, and now you're ready to go. Okay, let's go. Number 46, early epidurals. A study was conducted at Northwestern University in Chicago to determine if pregnant women in first-time labor could receive low-dose epidurals. And can't say that word, anesthesia, blah, 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 to control pain during childbirth without raising their chances of having a cesarean section. So epidural is a painkiller type of thing that prevents you from having some really bad pain whenever you're in labor. And what they want to know is whether or not giving that low-dose epidural earlier in the labor raises your chances of having to have a C-section versus natural birth. Okay? In the study reported in the New England Journal of Medicine, quote, 728 women in first-time labor were divided into two groups. One group received that spinal shot and then got epidural when the cervix dilated to about 2 centimeters. The other group initially received pain-relieving medication directly into their bloodstreams and put off epidurals until 4 centimeters if they could tolerate the pain. In the end, C-section rates were 18% in the early epidural group and 21% in the delayed group. The researchers concluded that pregnant women in first-time labor can be given a low-dose epidural early without raising their chances of having to have a C-section. So a C-section is considered like a major surgery versus giving birth naturally. And most doctors will hope that you can give birth without having to have a C-section because there is a little bit more risk involved. Now, there are obviously reasons why you would have to have a C-section. Actually, weirdly enough, my sister-in-law just had a baby today while I'm recording this, and had to be a C-section because my new nephew was a big old honking baby. Let's see. A, identify the research objective. They wanted to determine if pregnant women in first-time labor could receive that low-dose epidural without raising the chance of having to have a C-section. So there's been this question up until that study was done about whether or not giving an epidural makes your body less ready to have the baby naturally. Like, you get the epidural because you're in pain, right? And there's some question about whether or not relieving that pain too early might cause your body to stop trying to have the baby, right? And then you would be forced to have a C-section. So they wanted to study whether or not that's actually true. The B, identify the sample. The sample was those 728 women who were in first-time labor. C, the descriptive statistic was the C-section rate was 18% in the early epidural group and 21% in the delayed group. That was the descriptive statistic. 18% in the early group, 21% in the delayed group had to have a C-section. And D, state the conclusion. It's pretty much spelled out for you at the very end. The researchers concluded that pregnant women in first-time labor can be given a low-dose epidural early without raising their chances of having to have a C-section. Okay, so what I want you to do is remember that I'm going to put a link to this video in your Google Drive, or excuse me, your Google Classroom, just in case there's a part that you need to go back to. We are going to talk about questions 1 through 14 tomorrow, skipping 6, 7, and 8. So go ahead and make sure that you've got something written down for each and every one of these. Now I know I asked you to pause the video, so like right now this video I'm at about 35 minutes in, but obviously you paused the video several times, so that time could be a little bit longer. Depending on how much time you have left, you are welcome to grab a Chromebook and hop onto your Delta Math. You did not have a choice board this week because Wednesday was Veterans Day, state federal holiday, no school, yay, no choice board. But you do have 2 Delta Maths from Monday and Tuesday. If you are not done with those, please grab a Chromebook, get to work. That way you have free time at home. I don't have any Chromebooks in here. They're all charging in Miss Hines' room. She's just two doors down. So go out to the right. She's 2 doors down, room 357. Just creep in there. You'll be creeping in during her calculus class, I believe. And just grab a Chromebook. And yeah, if you have any questions, just hang on to them for tomorrow. Don't forget, you are going to be using this packet. If you lose this packet, I'm not printing you a new one. This was a lot of paper that I spent printing these. I don't want to have to print a bunch of these packets for you. So this packet will be uploaded into your Google Classroom as well at the very top under Statistics Textbook. If you have any questions, be sure to let me know tomorrow. Thank you for watching. I am 100% sure that your substitute is going to leave very, very nice notes about each and every one of you, because I know the 5 of you are, well, I'm assuming all 5 of you are there. But I know of all the 5 kids who should be in this class right now, that all 5 of you are wonderful people, and I'm sure that that substitute is not going to tell me otherwise, right? All right, have a good day. Bye.